Okay, I'm back. I'm on number 13. 64 to the negative 5/6 power. Okay, so the first thing that we do, this is the first time we've had to deal with a negative exponent or a negative power. So when you have a negative power, even before you change it into a radical, you have to rewrite the problem so that it has a positive exponent. So 64 to the negative 5/6 power is going to become 1 over positive 5/6 power. Okay? That's how we deal with negative exponents. You have to remember that rule. Now, if you notice, for the sake of time, I just figured out in number 12 that 64 to the 5/6 power is equal to 32. And if you want to know how I got that, refer to the previous video where I worked it all out here. So I know that when I work this problem out, 64 to the 5/6 power is equal to 32. So that would be my answer to number 13. I would just get 1 over 32. Okay, so 64 to the negative 5/6 power is going to be equivalent to 1 over 32. Number 14 on the back side of your handout. All right, there we go. Now, once again, I have a negative exponent or a negative power, however you want to refer to it. You have to first rewrite the problem as a positive exponent. So 16 to the negative 3 over 2 power would become 1 over 16 to the positive 3 over 2 power. Okay, and now I'm going to rewrite this problem as a radical. Okay, so the 1 will stay a 1. I'm going to have a radical on my denominator. The 16 will be my radicand. The 2 will become my index. I don't have to write the 2, but I will. And then the 3 will become the exponent for my radicand. Okay, I have to take my radicand now and I have to make a factor tree of it. So 16 factors into 4 times 4. 4's factor into 2 times 2. That 4 factors into 2 times 2. So when I rewrite this problem, I'm going to jump over here and I expand it out. I'm going to have a 1 in my numerator, and then my denominator is going to be, I'm going to have the radical symbol. The index is 2. I'm not going to write that. It's implied. A 16 becomes 2 times 2 times 2 times 2. But I'm going to have 3 of those because my exponent is 3. So I need to have another 2 times 2 times 2 times 2, and then I need to have a third 2 times 2 times 2 times 2. Okay, now my index is 2, so I'm looking for 2 identical numbers. So I have identical 2's, I have 2 identical 2's, I have 3 sets of identical 2's, 4 sets, 5 sets, so I have 6 sets of identical 2's. So moving to the outside, I'm going to move a 2 to the outside, and I'm going to move it outside. I'm going to move 6 of them out there. So in other words, I'm going to have 2 to the 6th power. Okay? So that means my final simplified solution is going to be 1 over, and then it's going to be 2 to the 6th power. And if I want to multiply that out, that'd be 4, 8, 16, 32, 64. So either one of those answers would be acceptable for number 14. Okay, number 15, 27 to the negative 2/3 power. First thing I have to do is I have to change this into a positive exponent. So that would become 1 over 27 to the positive 2/3 power. Okay, now I'm going to rewrite this problem as a radical. Okay, the 1's going to stay in the numerator, and then on the denominator I'm going to have a radical sign. The 27 becomes my radicand, my index is 3, and then that 27 is going to have an exponent of 2. Okay, now my next step is I have to take my radicand, which is 27, and I'm going to make a factor tree of that. So I'm going to go up here. 27 factors into 9 and 3, or 9 times 3. 3 is prime. 9 factors into 3 times 3. Those are prime. So I take this radical and I expand it. So when I expand it, I have a 1 in my numerator, my denominator is going to be a radical with an index of 3, and then 27 becomes 3 times 3 times 3, but since my exponent is 2, that means I'm going to have 2 3 times 3 times 3's. Okay, now I'm going to look for 3 identical numbers, because my index is 3. So I have identical 3's, I have 3 identical 3's. Those move to the outside, so I'm going to have a 3 times a 3 on the outside, which is 9. So this problem evaluates or simplifies to 1/9. That would be number 15. Number 16, this would be the first time that we had a base of -8. So here's how you're going to work out the problems when you have a base that's -8. So the first thing we do is we have a positive exponent, so we don't have to rewrite it. So we're just going to change this and rewrite it in radical form. Okay? So the index is going to be a 3, and then my base is going to be, or my radicand is going to be a -8, and then I'm going to have -8 to the 1 power. I don't have to write 1 power. Okay? Now, there's a trick that you have to learn on what to do with negatives. Okay, so what I do is, whenever you have a negative for your radicand, it's a very simple trick on how you're just going to make your life easier. What you do is you rewrite the -8 as +8 times -1. Okay, which really is just -8. And then what we're going to do is we are going to expand or factor the +8. Okay, so the +8 becomes 4 times 2. 2 is prime. The 4 becomes 2 times 2. So that would be, those would be prime as well. Okay, so then I take my radical and then I expand it. So when I expand it, I have an index of 3. I have 2 times 2 times 2. That gives me my 8. And then I have a times a -1, and I need to put that -1 in because I ultimately have to make it -8. Okay, 2 times 2 is 4, 4 times 2 is 8, 8 times 1 is -1, and now I'm looking for 3 identical numbers. So you could see I have 3 identical numbers here, so those go to the outside, so I get a 2 out there. And now I have a leftover. So when you have a leftover, the leftover stays inside the radical. Okay, so when I do this, I have a 2. I'm going to have a radical with a 3, or an index with a 3, radical with an index of 3, and then I'm going to have a -1 inside that radical right there. Okay, and now you could be done. But the question you have to ask yourself is when I have a negative, is there a number that I can multiply by itself 3 times to make -1? And the answer is yes. So you can just make this -1 times -1 times -1, which means you have 3 -1s here. So you could get rid of those and move a -1 to the outside. So my answer to number 16 is going to be -2. Okay?